25 Core AI Fundamentals for Modern AI Engineers. 1. Machine Learning, ML. AI systems that learn from data to improve performance without being explicitly programmed. Subsets include supervised, unsupervised, and reinforcement learning. 2. Deep Learning. A subset of ML using neural networks with many layers, deep neural networks. It's used in tasks like image recognition, natural language processing, and speech recognition. 3. Neural networks. Inspired by the human brain, these are the foundation of deep learning. They consist of layers of interconnected nodes, neurons, that process data. 4. Natural language processing, NLP. The field of AI that enables machines to understand, interpret, and generate human language. Examples: chatbots, language translation. 5. Computer vision. AI that enables machines to interpret and understand visual information from the world, for example, object detection, facial recognition. 6. Reinforcement learning. A learning method where an agent learns to make decisions by receiving rewards or penalties for actions taken in an environment. 7. Supervised learning. Machine learning where the model is trained on labeled data. Used in classification and regression tasks. 8. Unsupervised learning. Learning from unlabeled data to identify hidden patterns, for example, clustering, dimensionality reduction. 9. Generative AI. AI models that can create new content, text, images, music, etc. Examples: ChatGPT, DALL-E, Midjourney. 10. Transformers. A deep learning architecture especially effective for NLP tasks. Used in models like GPT, BERT, and T5. 11. Large language models, LLMs. Extremely large neural networks trained on massive datasets to understand and generate human-like text, for example, GPT-4, Claude, Gemini. 12. Bias in AI. The presence of unfair or prejudiced results in AI due to biased training data or model design. Critical in ethical AI development. 13. Semantic search. Search based on meaning rather than exact keyword matching. Powered by embeddings and vector databases. 14. Overfitting and underfitting. Overfitting, model learns the training data too well, including noise. Underfitting, model is too simple to capture the underlying pattern. 15. Transfer learning. Reusing a pre-trained model on a new task with limited data. Saves time and computing resources. 16. Prompt engineering. Designing effective inputs, prompts, to get desired outputs from AI models, especially LLMs like ChatGPT. 17. AI ethics. Study of the moral implications of AI systems, privacy, fairness, accountability, and impact on jobs and society. 18. Data annotation and labeling. The process of tagging data, text, image, video, to make it usable for supervised learning. 19. Edge AI. Running AI models locally on devices, phones, IoT, etc., instead of the cloud. Important for speed, privacy, and offline use. 20. AI model evaluation metrics. Ways to measure how well an AI model performs. Accuracy, precision, recall, F1 score for classification. MSE, MEI, R squared for regression. Blue, Rouge, perplexity for NLP. 21. Fine-tuning. Adjusting a pre-trained model on domain-specific data to improve performance in specialized applications. 22. Embeddings. Low-dimensional vector representations of high-dimensional data, text, image, audio. These capture semantics and are essential for tasks like similarity search and recommendations. 23. Vector search. A method of searching based on similarity between embeddings using techniques like cosine similarity or Euclidean distance. Used in semantic search and retrieval augmented generation. 24. Retrieval augmented generation, RAG. Combines vector search with generative models by retrieving relevant documents to enhance generation. Key in enterprise chatbots and LLM applications. 25. GPU/TPU infrastructure. High-performance compute units essential for training large AI models. TPUs, Google, are specialized hardware for tensor operations. Let's see the complete list. 1. Machine learning, ML. 2. Deep learning. 3. Neural networks. 4. Natural language processing, NLP. 5. Computer vision. 6. Reinforcement learning. 7. Supervised learning. 8. Unsupervised learning. 9. Generative AI. 10. Transformers. 11. Large language models, LLMs. 12. Bias in AI. 13. Semantic search. 14. Overfitting and underfitting. 15. Transfer learning. 16. Prompt engineering. 17. AI ethics. 18. Data annotation and labeling. 19. Edge AI. 20. AI model evaluation metrics. 21. Fine-tuning. 22. Embedding. 23. Vector search. 24. Retrieval augmented generation, RAG. 25. GPU/TPU infrastructure.